Okay, so this is video 6F, but we're basically just looking back at video 5F. And basically the point that we've been making is that integrals are antiderivatives and antiderivatives are integrals. So if you go back and you look at 5F, what I was saying is in this column I gave a whole bunch of functions. Y equals x squared, y equals 5x to the fourth, y equals sine x. And then you just sort of use your derivative rules that you've already learned to go that it's 2x. Derivative of x squared is 2x. Derivative of 5x to the fourth is 20x to the third. Derivative of e to the x is e to the x. And then if you're going to do antiderivatives, then you say that the integral of 2x is x squared. So the integral of 2x is x squared. And then we got to remember, as we've seen in some of my previous videos, you got to add it on your plus c. And so you have to watch those other videos to understand where that c comes from. Because the derivative of this is 2x plus 0. And so then you just sort of, you're just working backwards. Okay, so then we're going to look at some of them in general. So I say that y equals x to the n. And then I say that that gives me dy dx is equal to nx to the n minus 1. So let's look at that derivative procedure. Okay, 1. Let's change it to let's add in a little bit. I want to put some constant out front. Multiply the constant k by the exponent n. 2, subtract 1 from the exponent. Okay, there's my derivative procedure. So now my antiderivative procedure is going to be this run exactly in reverse. So instead of subtracting 1 from the exponent, I'm going to add 1 to the exponent. So n goes to n plus 1. And then instead of multiplying the constant k by the exponent n, I'm going to divide, which is the reverse of multiply, divide the constant k by the new exponent n plus 1. So what's that going to give me as a formula? That's going to say the integral of x to the n dx is going to be, k, let me remember my k. I'm going to add 1 to the exponent. And I'm going to take my constant k and I'm going to divide by that new exponent. And I have to add c. Okay. So then there are a couple. So then just some examples is I've got the integral of 5x to the 8th. That's going to be x to the 9th, 5 divided by 9 plus c. Now, so there's a few tricky ones in there. So I have the integral dx. Well, the integral dx is actually going to be the integral of 1 x to 0 dx. Because hidden in there is an unwritten 1. So I've got 1 times x to the 0 is 1, so I'm writing this in a really funky way. Well, what I do is I add 1 to the exponent. So my exponent was 0, and I add 1 to it, so I get 1. And then I divide 1 plus c, so I get x plus c. So the integral dx is going to be x plus c. And then similarly, the integral of 5 dx is going to be 5x c. Now, the other tricky one, what is the integral of 0 dx? Well, I'm going to write that as 0 times x to the 0. Whoops. And so what I'm going to do is I'm going to have x to the 1, 0 divided plus c. Well, divided by 1 is 0, so I'm just going to get the integral of 0 is c. Unknown constant, the derivative of some unknown constant, 0. Now, I'm going to throw a real big curveball to. I'm going to say, what is the integral of x negative 1 dx? Well, that's pretty simple. There's a 1 out front, and so I do x to the negative 1 plus 1 is 0. And I get 1 divided by 0 plus c. Oops. That's wrong. That's tough. I've got 0 divided by 1. 0 divided by 1, 0. But 1 divided by 0, find. But now, undefined. So in this case, it means power rule is applicable. Okay, and so in this video, but you should know the integral of x to the negative 1 dx is equal to plus c. Summarize. Find the derivative of ln x in a previous. The other way to write x to the negative 1 is 1. So there's a little bit of and then